very small window. Okay, just upload the chapter number 2. But before we proceed with our chapter 2, okay, let's recap something. So, okay, I put it this way. I know this is very small.
It's okay, madam.
But if I close the Google Meet window, maybe someone cannot enter the class. So I have to do something like this. See? Okay, so let's recap. Can you see my window or not?
Yes.
Yes, madam, yes.
We can. Wih, hilang semua benda. Apalah. Okay, bismillah. If we have, last time I mentioned something about elements. We have elements. Maybe I didn't put it in the right way. We have two types of elements. One is an active element and another one is a passive element. By the way, how are you? I forgot to ask you.
Okay, madam.
How are you?
Alhamdulillah.
Have you had your breakfast?
Alhamdulillah.
Yes, madam.
Brothers and sisters?
Yes, madam.
Oh, not yet. How are you? Are you there or not?
Alhamdulillah, good,
I
madam.
should give you the pop quiz. You can unmute yourself. We have 43 students. Maybe I shall test you guys. This way better. Okay, we have elements. One is active and another one is passive. What is that two elements of active element? Maybe I should call you. Siapa ada kat sini? Okay, Shiham Fakrul. What is that active element? Shiham?
Yes.
Shiham.
Active elements.
Okay. Active element. What is that too? Maybe you give only one. And then I will call another one. Another one maybe. Okay, Shafiqah. Shiham, the first element. What is active element? The example we had in our chapter 1.
Dependent.
Okay, Shiham.
Dependent source.
You can unmute yourself. Yes, you already unmute yourself. You just say something. We have two types of elements. One is an active element and another one is the passive element. Okay, I give you, because last time I didn't introduce you the word passive element. Passive element is, we have 3 examples. One of that, maybe I give you resistor. Okay, can anyone, okay, Shiham, you give me one example for active element. One, and then Shafiqah, apa nama? Are you guys okay or you guys just got afraid of that COVID in IIUM?
Okay.
Shafiqah. Second example, Shafiqah.
Active.
Third, maybe siapa kat sini? Ni agak senang. Okay. Azri. Third example, Azri. And then fourth is Shahir. Maybe. Okay. Okay, Shafika.
Resistor, madam.
Shafika and Shiham.
Madam.
This is battery.
Hello, madam. Can you hear us?
Hello.
Madam, can you hear me?
Tadi siapa saya panggil tadi? Dah lupa dah. Shiham,
Madam.
I didn't hear you.
I tak rasa
Cuba,
dengar.
Aku pagi lagi dah tak dengar bunyi. Madam, you can't hear me. Oh, why? Maybe you need to... kenapa tak dengar? Oh, all of you Alamak, madam, we can hear them. Oh, maybe my laptop problem. Maybe you can write down here in the chat box. Kenapa tak bunyi? I need to restart my laptop or what? Apalah, okay. Shiham, you write down your answer. And then Shafika. Okay, DC power source, yes. Shafika?
Voltage.
DC power source, yes. Shafika? DC power source is a voltage source also. Yes, same.
Oh, okay. Transistor.
Shafika, you gave me transistor. I didn't introduce you transistor. This is electronic, I believe. Okay. No, not transistor. Anyone can help Shafika? Just volunteer. Resistor. Resistor, I already gave the answer for passive element. This is resistor. Yes. Inductor. Okay. Capacitor and inductor. Yes. But this one number 3 and 4. Capacitor here. Inductor here. Yes. Okay. This is C. This is L. But what is number 2? AC. Yes. AC power source. Yes. Current source. Here. Current source. Current source. But for active element, yes, we have how many types of DC power source?
Two.
How many types of DC power source? Yes, one is this one. What we call this? Yes, we have 2 types. Yes. But what we call this? The circle shape here.
Independent.
This is, I give you a clue. The circle shape is a independent or dependent power source? Yes, independent. Good. It's independent. And then we have another one, also a DC power source, but this is dependent. Dependent power source. Okay. Say your current AC power source, we have independent and dependent. Okay, good. And we have passive element. Passive element is these 3, resistor, inductor, and capacitor. But what about passive sign convention? Passive sign convention for active element. What does it say? Passive sign convention, the current shall flow from where to where? If you have this. Oh, apa saya buat ni? The current shall flow from where to where? From positive. The current shall enter the negative and leaves the positive. This is the current flow for passive sign convention for active source. active source. But what about for passive element? Let's say we have resistor. Then the current will flow into what? Any answer? The current will flow into a positive, yes, positive, and leaves the negative. Yeah, good. Alhamdulillah. At least this is the most crucial part for our tak adalah pun crucial. Another one. Okay, anyone can tell me the current equation. Current equal to what? Current equal to? Yes, dq over dt. And if I have I versus t. Then what does it tells you for area under the graph? Yes, the charge, right? Charge. Area under the graph is the charge. How do you know? Coming from here, you have a charge which is equal to integral of I dt. Anything with this, you have area under the graph, okay, which is equal to the charge. Okay, what about if I have charge versus T? Then what is this one? The slope. Slope equal to? Yes, current. Coming from where? Coming from here. Because why? Because you have dq here. This is the dq. And over here you have dt. Okay, this is the fastest way lah. And then what about voltage? If you have voltage, equal to what? Anyone? Okay, good. dw over dq. And same, right? If you have a, what we call here, the w here and the q here, the charge, and then you will have the slope as your voltage. Okay. Okay. And what about if you have, what is P equal to? P? Yes, IV. If they ask you to derive this, how you derive power? Power is equal to, what is I? Oh, sorry, ni apa pula ni? Yeah, it's coming from that, but if you derive, I is equal to dq over dt, and then into dw over dq. And you cross these two, you have a dw over dt. And if you have what we call here, w versus time. W versus time. What is different? The slope. What is the slope? Power, yes. Good. So the slope is equal to power. Yeah, very good. And then if you have power versus time, then area under the graph is equal to W. Good. Okay, at least you know how to use your equation, inshallah. But please remember, usually charge have initial charge. You need to plus with the initial charge. Oops. Okay, this one. Remember to put into this. If they didn't give you the initial charge value, then you can find it, or maybe usually they will give you like equal to 0 or something. Okay, good. Now we enter chapter 2. Kenapa tak bunyi? Right. Chapter 2 is basic law. We have basic law. If I say basic law, means to say we have Ohm's law. Second, we have Kirchhoff law, Kirchhoff current law, Kirchhoff voltage law, fourth, voltage divider, and then current divider. If the question asks you to find using basic law, means that this is what they need you to apply. Do not use other laws. Other laws, maybe you're going to enter later on, you're going to enter chapter 3 or chapter 4 or later chapter, then you will confuse which one you're going to apply. If they ask you to use basic law, please do not apply coming from chapter 3 and 4, methods coming from chapter 3 and 4. Just use these 5 methods into your question. Okay. And then we have some ideal sources in series and parallel. Then, the last one is the Y delta transformation. But I think they skip this part, if I'm not mistaken. But later on, I will inform you on this. I think they skip this Y delta. I will confirm. All right. This part have a voltage of 2 volt here. Means to say, in ideal case, they will supply you exactly 2. Especially in the written form, 2 volt. But in real situation, in your life, you will never see exactly 2. You will see like 2 plus minus 0.01, something like that. So you will never get exactly 2. Okay, either voltage source in series can be added. Yes, that's number 1 information. Either voltage source in parallel is not a good idea. Okay, if you look at here, like we had in our example 1, if I'm not mistaken, in our chapter 1, if you look at here, plus minus, then plus minus, remember we add both sources, right? We just look at the polarity and then, we can add. But in series, basically, all voltages can be added. This is the main concept. But if you have in parallel like this on your right side, you need to have exactly V1 equal to V2 in order for this circuit to work. Okay, but in real situation, you will never get exactly 2 like this. You need to have a plus minus 0.01. Okay, so in real situation, please do not do a configuration something like this. It never happen. You will never get V1 equal to V2. So this is not a good idea to connect your circuit, even though it's possible in ideal case, but it's not possible in real case. Okay, so recall ideal voltage source guarantee that voltage between 2 terminals is at a specific 2 volt. Right? Okay, for current source, this is a different case, but it's same concept. If you have a current source of 3 ampere, it will give you ideally 3 ampere. It will not reduce plus minus 0.1. But in your real life, it will never happen. You need to it will give you like 3 plus minus of 0.1, something like that. So it will never give you exactly as that value. Okay, so either current source in parallel can be added. Something like if you configure on your left side like this, say this is a 3 amp, you need to have the 3 amps here also. Why 3 amps and 3 amps? Because you need to know that once you have a current source of 3 amps, leaving this 3 amps, then entering this source should have the same 3 amps. Should I discard? Yeah, just discard. Boleh masuk kan? Okay. Okay. Once I have here 3 amps, then the leaving current here 3 amps, then entering here should be 3 amps. And then leaving here also 3 amps. Okay. Meaning to say, if you put a current source of 3 amps here, it should have here 3 amps. That's our theory. But for real case, you will never see that 3 amps here and also 3 amps here. This one might be plus minus of 0.1. And because of that, over here, it's supposed to have a 3 amps of power supply, but it enters here 3 amps plus minus 0.1, then it will damage this part, the second current source entering here. So over here, it also will not get 3 amps of here. So the left side here will, this isn't a bad configuration of your circuit. Please do not configure like this in your real case. But for your written in a writing way, yes, you can just draw like this. But this is a bad way to configure. So how to configure your current source? This is the way you would do in parallel. For current source, you can connect it in parallel. Why? Because if this is a 3 amps, it will leave here a 3 amps. Okay, enter here 3 amps. And if this one also 3 amps, then it will leave here 3 amps. At this connected branches, you will have a 3 amps plus 3 amps. So over here, you have a 6 ampere. Okay, so if you have a parallel current source like this, then both can be added. And this one will be equal to 6 amps. So far so good, right? Current entering a circuit must be equal to the current leaving the circuit. This is the theory. Okay. Okay, resistance. What is resistance? Okay, basically all materials will resist the flow of the current given by some R value. R is the resistance value. Like I said, if we have even a true wire, also have some resistance in it. But a true wire usually will have a 0 ohms. That's why current can flow smoothly. This current can flow smoothly. But if you change maybe types of wire, then it will have some higher in resistance. Okay, so higher in resistance. Maybe you use a different type of a wire. Why you use different types of wire? Because actually you want it, maybe the power you're going to supply, the current is very large, then you need some a good wire to conduct the current or the power through that. Okay, later inshallah you will understand more. But what is a resistance value? Resistance is equal to this is a resistivity of that material in ohms meter, and then you have the length of this any material, okay, and then the area cross section. If you have a wire, then the cross section is this one, this cross section. But if you have sometimes resistor, right? Resistor also have some cross section inside of this one. And then maybe you have inductor or any elements, because all elements have its own resistance value. Capacitor also. So each one of that, they have some cross section of that area. And this one, you are familiar. The Ohm's law states that voltage across a resistor, maybe this is a voltage. It should be directly proportional to the current source. To the current source flowing through this resistor. This is current source. Okay, so proportional, V equal to IR. Only material with linear relationship satisfy Ohm's law. Note that passive sign convention. So if you have a resistor of this value, then if you plot this part, this is voltage versus a current, right? Voltage versus a current. Then the slope here is the resistance value. Okay. For non-linear, this one, the Ohm's law will not apply. Only the linear part. Okay. And if you look at here, this is a positive side of resistance value. And over here, the negative side of the resistance value. Yes, resistance can be in negative form. Yeah, maybe later on you will face this one. But I'm not sure they exclude the chapter or not. Because just to let you know that resistance value can be in positive and also negative. Okay, number 2. So two extreme possible way of this, R equal to 0 and R equal to infinity. This one I already tell you in our last class, but let's recap. If we have the resistance value of here, which is equal almost to 0, okay, can the current flow? Alamak, saya kena kecilkan. Okay, just keep. Can the current flow? You can write down here.
Yes.
If resistance value is very small, such that it is equal to 0. Yes, good. Yes, the current can flow. Good. And then what happened to this one? The V. What happened to the V? V equal to what? If R is very small, such that it equal to 0, then what happened to the voltage source here? Anyone? Anyone? Anyone can guess? Okay,
V equal to
I
I.
just put it this way. I think you're familiar with this. Okay. R is very small such that it equal to 0. Yeah, you write something. Just write something. V equal to what? Okay, I give you, yes, 0. V is equal to IR, yes, but you know that R is equal to 0, right? Because it's coming from here. So you apply the voltage Ohm's law, you will get 0 because this is I. Yes, you know that I can flow through this, but because of R is equal to 0, then voltage equal to 0. Good. And then what happened if you have a voltage source with this R? It's very large, such that it is equal to almost infinity. Then what happened to the current flowing here? What do you think? current can flow or not? Yeah, cannot flow. Okay, current cannot flow. Why? Because of the resistance here is too large, too huge, such that it's like a Great Wall of China, right? So this one will become an open circuit. Okay, open circuit. Open circuit, then the current cannot flow. Then current is equal to 0. Okay, so good. Okay, very good. Then this is what they mean by short circuit and open circuit. You need to know that if R is equal to 0, then this one will act like a short circuit. Short circuit. Ni macam sheet kan? Sorry. Short circuit. Short circuit. And this one open circuit. Okay, so conductance is another topic. Conductance is the ability of element to conduct electric current. It is a reciprocal of resistance R as measured by this and this. This means that if you inverse of that resistance, you will get inverse of resistance 1 over R, which is equal to conductance. So G is the conductance. What is the value for, no, what is the unit for conductance? Unit is this one. Okay. You know that R, the unit is this, and we call it ohms, right? But for conductance, we call it from here to here. So MHO, MHO. This is MHO, MHO, or Siemens. SIEMENS, okay, or just S, okay, Siemens. The power dissipated by, so far so good, clear? Okay, good. So the power dissipated by a resistor is equal to P equal to VI, or I square R, or V square over R. This one you just plug in the V equal to IR into the equation. Maybe here you will get V square over R. Then if here, then I square over I square R. So power absorbed by R is always positive. Why? Why? Power absorbed by, remember that power equal to positive IV. This is absorbed, right? Absorbed. So for resistance, it always positive. This is why, because if you have a passive sign convention and the current is entering what? A positive, right? Positive. And then you know that this is a resistor. Wait, I put it this way. The voltage across R will have a V. Sometimes we put it like this. Okay, and then because this is entering a positive, then you have a P equal to positive, and then this is a value for I, and then this is a value for V. So you have a positive IV. And what does it tells you on this positive side? It is absorbed, right? Absorbed. So this is what they mean by power always positive for resistive element. Okay, because why? Because of this. Okay, short circuit, this one I already explained. But you need to know you cannot connect voltage source to a short circuit. Because why? You will what? You cannot connect like this because you're going to drain out your voltage source. Okay, V will be equal to 0. So you will drain out your, maybe this is a battery. If you connect it this way, then you will drain out your battery. Okay, an open circuit. Yes, this is R equal to infinity, and ideal current source I equal to 0 for the open circuit. Yes. And recall you cannot connect current source to an open circuit. Why? If you have like something like this, Okay, current still flowing, but current will be equal to 0 here. And you cannot connect current source to an open circuit. Current source. If you put a current source here, something like this, then this one will give some value. So you will, this is not a good way to conduct, right? Because in series, it's supposed to have the same current source. But if we put it, you cannot connect something to an open circuit, something to meaning something like maybe your hands, this is you, and your hands is wet, and then you will be the conductor throughout your body. So that's also not a good way to configure or to accidentally touch the open circuit like this. So please be careful with open circuit. Okay. So far so good. Do you have any question? You can write down in your chat. Anyone? No? Okay, good. Okay, alhamdulillah. All right. Okay, now we have this. Okay. Can you guess what is I2? Okay. Over here. Yes. You need to apply what? Ohm's law. From Ohm's law, you know V equal to IR. And then you know that I is equal to V over R. Okay. And then what is the value for V? What can you guess? Sekejap. Okay. Can you guess what is the value for V? You can write down your answer. You look at here. Okay. And you know that this is the resistor. Okay, we give you the resistor value 2 kilo. Because why? I2 is flowing into a resistor. This one. I2 will flow into 2 kilo ohms. But what is the value for voltage? And you know that you need to apply passive sign convention. Okay. This is passive sign convention of a resistor. So the current will flow into a positive. Remember that, okay? So since this is I2 flowing into a positive, why positive? Because this is a resistor. Oh, cepatnya bagi answer dah. nanti. It's just the voltage. What is the value for that voltage? Remember, I know maybe you say here 10 because of 10 coming from here, right? But you need to remember something, that if we have anything like maybe this is 1 and this is a second and this is 10. If I say that this is maybe 3 volt across this resistor, okay, across this resistor, then what is the voltage drop across R1 here? What do you think? I just replace my word. What is the voltage drop across V2? What do you think? You have a 10 here, and then current will flow out, enter this R1. Then there's some voltage drop across R1, right? And I give you a clue. The voltage drop is 3 volt, right? And then what do you think the voltage coming out from that? What is this voltage? Yes, 7 here, good. Then this 7 is basically the voltage drop across this. Why? Because this one usually a ground, okay? A ground. So there's some additional voltage drop, which is at this R2, this is the voltage drop, because you're going to see this 0. Later on, I will introduce you the KVL. This is where the voltage drop coming out from here. So we go back to our example here. So what is that voltage drop across 2 kilo ohms here? Voltage drop across 2 kilo ohms. Can you see? Mungkin tak nampak Anyone? Okay, saya padam. Okay, pening. What is the voltage drop across 2 kilo ohms? I2 will enter this 2 kilo ohms, and you expect from passive sign convention, it will have here a positive. But now you have a negative, right? Negative 0.5882 volt. And this is positive side, this is negative side. Do you think this is a negative 0.588 or is it a positive 0.588? A positive or negative? Negative, okay, negative. Okay, majority says negative, right? Yes, you need to just apply whatever you see here. So since this is a negative voltage, then you just write down the negative value. So over here you have a negative 0.5882. Okay, remember to put all. Okay, that's good. So this is a negative. Then you use your calculator and then you will get I2. Sorry, I didn't write I2. That's why maybe you confused, right? Okay, number 2, V6. What is V6? Look at the current flowing. Okay, and then apply passive sign convention. First, the current flow. And then second, passive sign convention. Third, applies Ohm's law. So current is flowing from left to right. This 1.61 milli, right? And then enter. Is it a resistor, right? Yeah, resistor is a passive element and it should have a positive here. Okay. And what do you think V6 equal to? V6 is okay, V6, you know that Ohm's law, I and R. What is I? Okay, you can write down what is I equal to. Anyone? Is it a positive I or negative I? Yes, 1.61 milliamps. Is it a positive? Yes, positive. You just take whatever the value is. So this is a positive 1.61 milli. Please remember to put milli. So over here, 1.61 milli into R. What is R? 6K, yes, good. Into 6K. So you can cross this together and you just multiply and you get the answer. What is R4? R4 here. Okay, mungkin pening. Penuh sangat. So what is R4? You can apply Ohm's law. R4 is equal to V over I, yes. But what is V? V equal to? Okay, 13.53. Good. A positive. How do you know positive? You look at the current, right? The current here. Current is flowing into R4. Yes, passive, passive sign convention, good. And then you're supposed to have a positive. And since this is a positive, then you just take whatever value here. You have a positive 13.53 and then divide by the current. What is that current value? Current equal to? Anyone? Current equal to? 3.38 milli. Is it positive or negative? Is it positive or negative? Yes, positive. Why positive? Because you take whatever value they give you here, 3.38 milli, and then just look at the current direction. Current is flowing through here. And then since this is a resistor, you should apply passive sign convention, which has positive. Then, yeah, you just apply that and then compare. This is yes, positive. If this is negative, then you write down negative. And then you do the calculation. If you divide by milli, then you should have your answer in kilo ohms. So yeah, use your calculator. I will not give you the answer because it's only the math. What you need to know is the concept, how you get that. Okay, V2. Sekejap, dah penuh. V2. What is V2? Okay, anyone? What is V2? V2 equal to IR, yes. And then I equal to this, right? Because you have a current flowing through this, and then the current is entering a resistor. Yeah, okay. 3.38, it's supposed to be 3.38, and this is a positive. And then, is it a negative current or positive current? What do you think? Is a current should be a positive. Yes, this one. You just take whatever we have there. But why is this a negative here? Why do you put the negative first? Negative here because of this. And then the current is equal to positive 3.38 milli. And then into the resistor value. The resistance is 2 kilo ohm. The negative is this one because of what? Because you have a passive sign convention supposed to have a positive, but now here is a negative, then you just put the negative. Okay, so Muhammad Shafiq answer. I think the only wrong is the negative 2K. The resistor should not be negative here because this is a positive. Okay, so the answer is this. Is it clear? Or do you have any question? Question? No? Or yes? Clear. Okay. Alhamdulillah. All right. Last, I8. Where is I8? Okay, I8 here. What is I8 equal to? Okay. V over R. Then? Okay, good. Good. Then what is the voltage equal to? Sorry, bunyi bising. What is V equal to? The first step, you need to look at the current flow, right? What is the I8 current flowing from higher to lower or lower to higher? What I mean is from up to down or from down to up. Which one? Downward. Okay, it's going downward like this. So the current is flowing into a resistor. So you're supposed to have a positive here. Okay, good. And then what should you do? You look at the voltage. Is it a positive voltage or negative? What is the value across these 8 kilo ohms? The voltage value is? What is the voltage across 8 kilo ohms? Yes, 10.59 is a positive, good. So 10.59 divided by what? Resistor of 8K. Yeah, good. So it's a positive value. So anything divided by kilo, you should have the answer in milli. Okay, in milli. All right. So far so good. Any question? You can look back at our recording, inshallah, later. So to formalize for this course, you will come across with this and this wording, but basically they are same. And what is that circuit? Circuit is anything you have elements connecting with wires, and you have some nodes here, and then branches. You have, this is a branches, and maybe another thing. So any configuration of a network, something like this, or a circuit like this, we call it a network and a circuit. Macam itulah. So network are composed with nodes. This is nodes, branches, and loops. Okay, later we show you what is loops, what is nodes and branches. Okay, a branch is any element. A branch is any element. If you have a voltage source, then this is one element. If you have a resistor, yes, another element. Or capacitor, or inductor, or current source, then this is all elements. How many elements do you have in here? Can you count? Kejap, sorry. An element is a branch, okay, and a branch is an element, okay. So you have 1, 2, 3, 4, 5 branches. A branch is any element. This is element, and element. So you have 5 branches. Okay. Second, a node. A node is a point of connection between 2 or more branches. Okay. If you have this is one branch, and then you connect to another branch like this, then in the middle here is a node. This is a node. What is a node? A node is any two or more branches connected at a single point here. So if you have two branches like this, and maybe additional branches here, or maybe here, then that connecting point here is the node. Okay, clear? Okay, so what is a loop? A loop is a closed path. Make sure this is a closed path in a circuit. So meaning to say, if you have something like on your left side here, this is one closed path, right? You have 1, 2, 3 connected, and then this is closed. Okay, same as on your right side here. You have this, maybe you start from here and then you do like something like this. It is a closed path, then this is another loop. So you have 2 loops. We call here an independent loops. Independent loop. It does not depend on other loops. What is a dependent loops? It depends on other loops. Meaning to say, this is also one closed path, right? Okay, so you have how many dependent loops? Saya sebut saya sebut betul. Okay, just stick with this one. So dependent is depending on another loops. So meaning to say you have 1, 2, 3 here. Okay, because it depends on other loops too. Okay, so this is what does it mean by branch, node, and loop. But if you want to calculate, there's some equations, which is branches equal to loops plus node minus 1. Okay, this is 1 minus 1. So in our configuration just now, we have how many loops? We have 2 loops. Just ignore the outer loops here. We have 2 loops. And then we have how many nodes? How many nodes? Sorry. We have 1 node, 2 nodes, 3, and this one is a node, right? 4. So you have plus 4 minus 1. So let's calculate what is the branch equal to. So 6 minus 1, you have 5. Do you have the right answer? Yes, most of you said 5 here, right? So this is branches number. What is a branch? Branches is a element. 1, 2, 3, 4, 5. So this is correct. So either you apply this theorem or you calculate by your own. Or you calculate by your own and then you reconfirm using the equations. Both are correct. Okay, good. Okay, how about this one? How many branches you have here? How many branches? You can write down. Maybe I should check back your chatting box here. If someone answer means that you present, you are in the class. It's like your attendance, right? So you have here 1, 2, 3, 4, 5. Yes, you have 5 branches. Okay, good. How many loops you have? How many loops? 3. Majority of you say 3. Why 3? Because you have 1 here, 2, and 3. Why not this one as a 1? This is another 1. And this is another. Why not that 3 here? What do you think? It is not, right? Because why? Because a node is actually when you have 2 or more branches connected at a single point here. So you have over here maybe 3, 1, 2, 3, but it's still a branches and it's still one single node. Same like this one. You have 1, 2, 3, 4. 4 elements here connected at a single point. This is one single point. Okay, this is one single point. So you have a 3 nodes kat sini. 1 here, second here, and third. Okay, good. What about loops? How many loops? Independent loops. How many loops? 3. Yes. 1, 2, 3. Okay, good. Okay. All right. Let's calculate. Branch is equal to loops. Loops plus loops we have 3 plus nodes. Node we have 3 minus 1. So we have 6 minus 1 equal to 5. And we have, yes, 1, 2, 3, 4, 5. Yes, 5 branches. So this is to confirm that your calculation is correct. Okay, what about, oh, this one is another way you draw your circuit. So please do not tell me that if I give you the question, some configuration like this, and then you compare with this one, and you say that your circuit is difficult. This one is difficult than this one. Basically, they are same. Just the way I put it together, this one will become one single point. But here, it seems like you have 3 points at this part. But actually the same, right? Okay, good. Now this one. How many branches? How many branches? Or maybe like this. Kita tukar sikit. I know majority have given the 7. How many loops do you have? You want to calculate, right? Okay, we have 4 loops plus how many nodes? This is 4 loops. How many nodes? Nodes. Okay, nodes. Are you sure you have 3 nodes? One of your friends said 4 loops and 4 nodes. Okay, we have this one, 1. We have this one, 2nd. This one, 3rd. Okay, 3rd. Then where's that number 4? Middle of where? Middle of here, right? Yes, here. Middle of this. Why? Because remember, we have two branches connected together at a single point here. So meaning to say, this is one branch, right? And this is another branch. Meaning to say, in the middle here is a one single node. So you have one here, one pula dah. 1, 2, 3, and 4 here. So you have 4, then minus 1, then you have 7 branches. And your answer is 7, right? Yes, 7. Good. So you have 7 elements. No need to count one by one. But to confirm, yes, you can count. Okay, Kirchhoff law. We have two types of Kirchhoff, the current and the voltage. But what is that too? Okay, for current law, anything entering or leaving the nodes, this is a single node, will be equal to 0. The summation of all current, which is leaving or entering the nodes, must be equal to 0. Okay. Summation of all current enters or leaves the nodes, then it should be equal to 0. So this is your theory part. Or you can put it in this way. The summation of all current enters should be equal to the summation of all current leave the nodes. So this is two way you write down your the theory of this. So meaning to say, if you have I1 which is entering, I2 also enters, I5 also enters. So the summation of this should be equal to this. So you will get this. Okay. Or the summation of this, this, and this will be equal to 0. Okay. Just the sign different. If you say that enters is positive, then leaving should be negative. Okay. This is entering this node. This is leaving this node. So this is positive and this is negative. All right. And we have two types of Kirchhoff current law. Two types means if you have something like a boundary like this, then we also consider that as a, we can apply that as a KCL. Why? Because it's maybe the current is entering a node or leaving it. Or maybe the current is entering a boundary or leaving the boundary. So you still can apply KCL. Like this one, you have this one entering the boundary. And you can see, right? There's boundary here. Then this one current leaving, this one enters, this one leaving. So this plus this must be equal to this one plus this one. So you have I1 plus I3, which is this, and I2 plus I4, which is this. Okay. I usually will use number 2. Number 2 means this one, this equation. I will not really use this one, no. But both are correct. Just to say that entering must be equal to leaving. Okay. Given that ascension node is the point between 3 or more branches, you need to apply KCL to each ascension node in the circuit. What is ascension node? Ascension nodes is that 3 nodes. 3 nodes. Bukan. Ascension nodes is when you have 3 or more branches connected at a single point. Okay, 3 or more. The word essential is a 3 or more branches. This is one branch, 2 branch, 3rd branch connected at a single point. So ascension node, this is a node, right? So that is what essential node. So you have this one, number one. Second is this one, and the last essential node is this one. Okay. What about this part? Is this a essential node? What do you think? What do you think this one? Is it essential node? No. Because why? Because it has only two branches. So this is not essential node. Okay. So what is number one? Equation. Apply KCL. So what is the first KCL equation here? Anyone can type? And maybe another one can type number 2 and another one can type number 3. Volunteer. Yeah, you just write down. I will consider this as you are in the class. Your attendance, right? Cepat. Just write down. Number 1. What is KCL at number 1? And then number 2, and then number 3. Number 3 here. Volunteer? No volunteer? Okay, maybe I volunteer myself. Number 1. I1. This is I1. Remember, current entry should be equal to current leaving. So you have a I1, then equal to I6 plus I8. Okay. Okay, so what is KCL at number 2? Okay, Zaido. Then number 2? I6. Okay, the clue is I6 is entering. What about other current source? Okay, good. Right. You have I6 plus 5 milli. Please remember to put milli. Why you put 5 milli? Because why? Because it's a prefix. Remember prefix? You need to include in your equation. So I6 plus 5 milli equal to I3. Yeah, good. What about number 3? Note number 3. Essential node number 3. What is that equal to? What is KCL at number 3? Anyone? This one, if you write down the answer, this one just to test your understanding. If you put it correct, that's good. But if you make mistake, then you will learn from the class. And then you will forever you will remember. That's the best way to learn. When you learn something and then you test yourself. Okay, so what is the essential node number 3? Okay, I3. Okay, then I3 plus I8. Okay, and then equal to I1, but you miss another branch. Where's that branch? Yes, that 5, right? Remember to look at what is connected to this point. Okay, so you have one branch here, another branch, and another branch. So you need to have at least four equation. So since majority have only one says 4 elements. So you need to look at that all 4 branches. So since the number 1 here, you have a I1. Okay. Number 2, you have I8. Okay. And then number 3 here, this is 5 milli. And then number 4, you have this I3. So based on that, you can do your equation. So the answer is I1 plus 5 milli equal to I3 plus I8. Yes, Engku Sufyan, yes, you get it correct. Good. Okay, next. What is a voltage, Kirchhoff voltage law? It is algebraic sum of all voltages around a closed path. Make sure it is a closed path or a loop. that must be 0. So mean to say, if you have something like this and it's close, okay, remember close, and maybe this one V source, and then maybe this one plus V1, and then this one maybe V2. Okay, so since this is a closed path, then you apply Kirchhoff voltage law. So if you look at here, anything you look at the potential first. So you have a negative here, negative Vs, and then the second one is this one, you enter a plus V1, and then you enter this plus sign V2, it must be equal to 0. So summation of all voltages across that elements in the loop, in the closed loop, must be equal to 0. So this is how you apply your KVL. Okay, let's try apply KVL to each loop in the circuit. Okay, the leftmost. Anyone to try? And I put it this way. You can put it any way you like, no problem. Volunteer? Yeah, you all of you volunteer. You volunteer, you will get your knowledge there. Okay. Look at the current direction. This is imaginary current direction, and the current is entering a negative. And you have what value here? A 10. And then this current is going into here. Yes. Okay, good. And then go through here plus V8 and must be equal to 0. Yeah, so all of you got it correct. You have a negative 10 minus V2 plus V8 equal to 0. Yeah, that's number 1. Okay, number 2 in the middle. If I put it this way. Okay. Volunteer yourself. Actually, in this life, it's good to volunteer yourself. In anything you do, you just volunteer yourself, because when you contribute, and then you will get the reward. If not the reward from here, maybe the reward in here after, right? So you have a negative V8 minus V6, and then this is a plus or minus? A plus VI. Yeah. Okay, I will. Yes, majority of you got it correct. Good. Okay, last this part. Okay. Start from here. Negative. Negative VI, yes. And then you have a negative V3, yes. And then plus V4 equal to 0. Yeah. All of you got it correct. But what if I put it another way? This is a loop, independent loops. What if I say dependent loops? Dependent loops. Maybe just the last one, outer loops. I think majority of you got it correct. Just last one, outer loops. Dependent bukan. Dependence loop of outer loops. You have a negative. Start from here, negative 10, and then you get it. This one, negative V2, then you have a negative V6, and then negative V3, and then plus V4.
Positive V4.
And then equal to 0. Yeah, good. Okay, very good. Because I actually want you to write down why, because I want to look at your equation. please do not write down with the unit. Okay, so you should write down like this: a negative 10 minus V2 minus V6 minus V3 plus V4 equal to 0. Please do not write down with prefix, because why? Bukan prefix, the unit. Because why? Because this is only the value, okay? Value. The last answer should be in unit. This is vote. Okay. All right, good. At least we learn something with each other. What is this one and this one? This one is a dependent loops. Coming from where? It comes from, remember we have 1, 2, 3 independent loop, right? But if you consider the dependent loops, just now independent loops, we have dependent loops, another one, and then we have the last one. Okay, so you have 6 loops. It does not say independent or dependent. So if loops, then macam tu lah. Tak apalah, apa-apa je kita raikan dia. Okay, this one. Apply KVL. Oh, we already 11:20. Okay, I think we just break here. We stop our class here. Do you have any question before we stop? It's already 11:20.
No,
eh?
madam.
For those who didn't answer anything or write something on the chatting box, please write down something so that I know that you attend the class. Alhamdulillah, all clear. Good. Okay, with that we finish our class with tasbih kafarah and surat al-as. Subhanakallahumma wa bihamdik, asyhadu an la ilaha illa anta, astaghfiruka wa atubu ilaik. Al-as innal insana lafi khusr illa alladhina amanu wa amilus salihati wa tawasaw bil haqq wa tawasaw bis sabr. Alhamdulillah Rabbil Alamin. By the way, how's COVID in your place? COVID. How's are you in block G for Asia? Huh? Anyone? For brothers, block apa yang ada dua brothers tu? No okay, Alhamdulillah. If you come across with someone with maybe potential as that, you just be careful, but do not say bad words to them, because they are just victims, right? Okay, so take care of yourself, and then home sweet home, okay. For those who are in mahalla, just be careful. Okay, Assalamualaikum. Take care. I need to stop, right?
Thank you,
Okay, stop
madam.
recording first.